Welcome to the Vet Help channel, your trusted source for veterinary education and animal health awareness. Today, we delve into the history and science of a monumental achievement in veterinary medicine, the eradication of Rinderpest. This disease, once a devastating plague on cattle populations, is now a story of global triumph. So, what exactly was Rinderpest? Known historically as cattle plague, Rinderpest was a highly contagious and often fatal viral disease. It primarily affected cloven-hoofed animals, especially cattle and buffalo. The culprit behind this disease is the Rinderpest virus, a member of the genus Morbillivirus within the family Paramyxoviridae. This places it in the same family as other significant pathogens like measles virus and canine distemper virus. Its structure, typical of paramyxoviruses, allowed it to be incredibly effective at spreading and causing severe illness. Rinderpest once had a formidable global presence, causing catastrophic losses in cattle populations across Asia, Africa, and Europe for centuries. These outbreaks led to widespread famine and economic collapse in societies dependent on agriculture. The disease spread primarily through direct contact with infected animals. The virus was present in virtually all body secretions and excretions, including saliva, nasal and eye discharges, urine, and feces. This meant that close proximity in herds, shared watering holes, and contaminated environments were major routes of transmission. Even indirect contact through contaminated feed, water, or equipment could spread the disease. Its high contagion rate made it a constant and terrifying threat to livestock industries worldwide. To understand how Rinderpest caused such severe disease, we need to look at its pathogenesis. The virus typically entered the animal's body through the respiratory or oral routes. Once inside, its first stop was the local lymphoid tissues, such as the tonsils and lymph nodes in the throat area. Here, it began to replicate rapidly. From these initial sites, the virus would enter the bloodstream, a condition known as viremia. This allowed it to travel throughout the entire body, systemically targeting cells of the immune and gastrointestinal systems. The virus had a particular affinity for lymphoid tissues and the epithelial cells lining the digestive tract. This led to widespread destruction of immune cells, severely weakening the animal's defenses. In the gut, this cellular damage resulted in severe necrosis and the formation of erosions and ulcers, which is what caused the classic and debilitating symptoms of the disease. The clinical signs of Rinderpest were distinct and progressed rapidly. An infected animal would first develop a very high fever, often exceeding 40 degrees Celsius. Within a few days, characteristic erosive lesions would appear in the mouth, on the gums, and on the tongue. This made it painful for the animal to eat or drink. This was accompanied by a thick discharge from the nose and eyes. As the infection progressed and the damage to the gastrointestinal tract worsened, the animal would develop severe, often bloody diarrhea. This led to rapid dehydration, profound weakness, and emaciation. Without intervention, death would often occur within 6 to 12 days due to dehydration and secondary bacterial infections. The severity of these signs made Rinderpest a truly dreadful disease to witness. Diagnosing Rinderpest in the field often began with recognizing this classic set of clinical signs, especially when multiple animals in a herd were affected. However, for a definitive confirmation, laboratory tests were essential. Veterinarians would collect samples such as blood, tissue from mouth lesions, or swabs from nasal and eye discharges. In the lab, one of the most common diagnostic tools was the enzyme-linked immunosorbent assay, or ELISA, which could detect either viral antigens or the antibodies produced by the animal's immune system in response to the infection. Another highly sensitive and specific method used was the reverse transcription polymerase chain reaction, or RT-PCR. This molecular technique could detect the virus's genetic material, providing rapid and accurate confirmation of an active infection. Given the viral nature of Rinderpest, there was no specific cure. Treatment was limited to supportive care, aimed at managing the symptoms and preventing secondary infections. This included providing fluids to combat dehydration, administering antibiotics to control opportunistic bacteria, and offering nutritional support. However, the prognosis was often poor. Therefore, the global strategy shifted from treatment to prevention and control. The cornerstone of this effort was vaccination. The development of a highly effective and stable vaccine, the tissue culture Rinderpest vaccine, or TCRV, was a game changer. This vaccine provided long-lasting immunity. Alongside mass vaccination campaigns, control efforts included strict quarantine measures, restrictions on animal movement, and, in some cases, the difficult but necessary culling of infected and exposed herds to halt the spread of the virus. This multi-pronged approach, coordinated on a global scale, was the key to its eventual defeat. The legacy of Rinderpest is one of the greatest success stories in the history of veterinary science and global health. In 2011, the Food and Agriculture Organization, FAO, and the World Organization for Animal Health, OI, officially declared Rinderpest eradicated from the planet. This marked only the second time a disease had been globally eradicated, the first being smallpox in humans. This incredible achievement was the result of decades of tireless effort from veterinarians, scientists, governments, and international organizations working together. It demonstrated that with coordinated action, scientific innovation, and political will, humanity can overcome even the most daunting animal diseases. The eradication of Rinderpest has saved countless animals, secured the livelihoods of millions of people, and stands as a powerful symbol of what we can accomplish through global cooperation. Thank you for joining us on VetHelp for this complete overview of Rinderpest disease. Stay connected with VetHelp and subscribe to the channel.